From Microbe TV, this is Q&A with A&V. I'm Vincent Racaniello, and joining me tonight from New York, Amy Rosenfeld.
Hello, Vincent.
With brand new lights provided by listener
Usually when people
Rich.
say hello, they say back hello.
Hello, Amy. How are you today?
Never mind.
With brand new lights donated by Richard. Thank you, Richard, to make
It's
Amy
very nice.
look
Thank
nice
you.
and warm. You look very warm. Is it hot there?
Yes, they turned off the air conditioning because of COVID. So now they're just recycling air from outside that is very humid right now or very warm, out of season.
They turned off the recirculating air because of COVID.
Mm-hmm.
What do you think about that?
It's fine. However, they don't seem to know how to regulate it in awkward transitional states when you go from winter to summer and summer to winter.
I didn't recall that they shut off the air before, did they?
It's been off since COVID.
Okay.
I know this because I called facilities.
And what did they say? It's off because of COVID?
Mm-hmm.
Okay. I wonder how many COVID-acquired infections have been in Hammer. They wouldn't know, I guess.
How would you know? How could you ever possibly do that?
Nope, you wouldn't know.
You'd have to have everybody who was in Hammer never leave Hammer.
Yeah, exactly right. Well, let's get going here. Thanks to the moderators who are here tonight. Les, Steph, Tom, Vanity Nutrition, and Frank. Amazing. You guys are all here. We really appreciate your help. And welcome back, everybody, to the corner of the internet where you can talk virology. So let's jump in to gout from fried okra. How concerned should people after full COVID recovery be with increased heart disease risks and other potential COVID health issues popping up later in life? What do you think, Amy?
Probably not that concerned unless you had some kind of symptoms as you were early in recovery. Depends on what you mean by later in life. Like in 5 years? No.
So what do you think of this idea that you recover and you have no long COVID, then all of a sudden years later something pops up? Who knows if it's COVID or something else, right?
So you're trying to ask about like post-polio?
Yeah. I mean, there's a precedent for that. It could happen, but we have no...
It's not really clear what post-polio is.
It's paralysis after polio, right?
Yeah, but you don't really know that it's caused by polio.
No, it's just that it happens in people who had polio. It doesn't happen in people who did not have polio.
You can never exactly prove it.
Thank you, Rob, for your contribution and always promoting fungi. We appreciate that. Check out the latest TWIV tomorrow because I show that the coin that Les, our moderator Les, gave me, the polio commemorative coin. Andrew thinks you're going to be wearing tangerine.
Nope, it's gray cashmere today. Well, you should tell them that yesterday was the anniversary of IPV. It's IPV Day.
April 12th, 1955 was the day the clinical trial results were released for IPV. And they were released in Rackham Hall at the University of Michigan. The press was all there. The data were released, and then the vaccine was approved the same day. And shipments went out. Yeah. So let's see. 55. How many years would that make? I can't do math in my head. So that would be 1955. Oh, I can't do it that way. What is this year? 2022 minus
77.
77 years. Wow. 77-year anniversary. And of course, Jonas is gone. And so is polio from the U.S. Very cool.
Maybe, maybe not.
Okay. Any good news to announce today? I don't have any good news. Do you have any good news?
Nope.
Okay. A lot of people saying hello to each other. Principal manager liked the last clinical update. Glad you liked it. What did you like about it? Okay, Kang says, how are viruses from patient or animal samples cultured without bacterial or fungal contamination?
You had drugs.
You add antibiotics and antifungals, and you do a 0.2 micron filtration?
Depends on what kind of virus you're looking for.
Yeah, you could if the sample were amenable to filtration. But yeah, you put a lot of antimicrobials in the culture, and that does it. Demon is part of the Amy fan club.
It's cute.
Do you have T-shirts?
Sure.
Shane says, did you see the Finnish Swiss study about infectious virus and vaccine status? Yes. Amy sent the final paper to me a couple of days ago, and you may recall we did the preprint on TWIV. Looks like during Omicron, FFU was not significant between vaxxed and unvaxxed, but was for boosted. What do you mean the FFU was not significantly different? You mean reduced? Yeah, so that's a boost was necessary to give you immunity against Omicron, remember? And then in the case of the boost, the third shot, then you had a reduction in shedding infectious virus compared to unvaccinated.
Unfortunately, that's not really the right comparison.
What's the right comparison?
Should have been to people who were vaccinated only twice.
They didn't do that?
Well, apparently not if you're highlighting between vaccinated and unvaccinated.
I'm looking up the paper now so that we can go right to the source. I think you sent it to me and Daniel together, right?
Yes.
Yeah, here we go. Octogenarians. Here we go. Infectious viral load in unvaccinated and vaccinated individuals infected with ancestral Delta or Omicron. Okay. Here we go. We quantified infectious virus in SARS-CoV-2 infected individuals during the first 5 symptomatic days. In unvaccinated or vaccinated individuals infected with pre-variant of concern, Delta or Omicron. Unvaccinated individuals infected with pre-VOC had lower infectious viral load compared to Delta infected unvaccinated. Full vaccination reduced infectious viral load for Delta compared to unvaccinated. For Omicron, reduced infectious viral load was only observed in boosted but not fully vaccinated individuals compared to unvaccinated subjects. In addition, infectious viral load was lower in fully vaccinated Omicron compared to fully vaccinated Delta, suggesting that other mechanisms than increased infectious load contribute to the high infectiousness. So you need a boost to have an impact on.
Well, that's not exactly
shedding.
what it said, but it's not exactly what it said. But that's okay.
Do you expect a new, possibly more dangerous variant anytime soon?
Not necessarily.
I don't expect a new, possibly more dangerous variant. We haven't had one yet, which is not to say we won't, but I don't expect it, no, at all. I don't know why you would say that.
I don't, well, what do you mean when you say we haven't had one yet?
We haven't had a more dangerous variant. We have had variants that have been more fit than previous variants, and Omicron is clearly immune evading and evading antibodies, but not
Well,
more
doesn't that make it
dangerous.
more dangerous in theory? Or doesn't that make it more dangerous?
I don't believe so, no.
Well, how do you
Because
define dangerous?
the vaccines still protect you against severe disease and death. So it's
But
not
you
more
needed a
dangerous.
boost in order to, you just finished telling me you needed a boost.
Well, I don't consider that more dangerous. I consider more dangerous if it's causing more severe disease.
But it would have, but by your definition or or by extrapolating what you just said, if we hadn't had that boost, you would have, that it would have caused more disease.
I don't consider that more dangerous. When people say that, they're talking about more virulent. They're not talking about
Well,
effectiveness
it
of
could have been more
vaccination.
virulent, except for the fact that you intervened. So you really can't say anything because there was an intervention.
What kind of intervention?
The boost was the intervention. So clearly it was considered more dangerous, and you will agree it was considered more dangerous because you just finished telling me you needed a boost.
There are actually some data which suggests that you didn't even need a boost to prevent severe disease and death. Depends on the study you look at. And as Richard Plemper said today, you can't compare studies. They're all done slightly differently. I'm triple vaxxed and
You have to
work
be able to compare studies.
wants us to go into office without masks. We have poor ventilation. Does that mean I have a high chance of catching COVID? So this phrase catching COVID really set Steve Morse off the other day. What do you mean catch COVID? Do you mean be PCR positive? Or do you mean have symptomatic disease? So
Well,
you
you might
can't.
want to tell them who Steve Morse is.
Morse is a professor of epidemiology at Columbia. Because there's a difference between simply being positive and having symptomatic disease of various severity. So you're triple vaxxed, but still you can be infected. So if that's what you mean, then yes, you can be infected. But if you're talking about severe disease and death, no, you're not likely to have that because you're triple vaccinated. You and I have the same birthday. Wow, pretty cool. You're 59. This sucks. SARS-CoV-2 Delta Omicron recombinant identified in a transplant patient treated with sotrovimab. I don't know if it sucks or not. It depends what the properties of the recombinant are, right? It may have arisen randomly. I mean, immunocompromised patients may be more susceptible to multiple infections. So I wouldn't say that it's worrisome until you know more about it. From Montreal, world's best bagels. Is that true, Amy?
No.
We are now seeing the first cases of flu in 2 years. Can you speak to the interaction between influenza and COVID? Competition or public health measures? I'm not aware of any virological competition. Are you,
Yeah,
Amy?
there is. There's interference.
At what level?
An infection.
Who interferes with who?
COVID interferes with flu infection. It's work done by Ben Tenuver and Ellen and various other people, and Ellen Foxman and various other people.
And what do you think of their conclusion?
Well, it would be good if Ben would drop the paper.
Maybe it's not being accepted.
I'm sure it's accepted. He tweeted it was accepted, so I'm sure it's accepted. And he's not the only person who's observed this. There's a lot of epidemiological studies that have observed this.
Does he have a mechanism?
I believe he does. You have to wait for the paper.
Okay. Is that a twivable paper?
Well, when it comes out, we'll look at it and make sure it's a twivable paper. If it's just RT, no.
Yeah. So he asked competition or public health measures. So this is biological competition that we're talking about, right? It's not just a matter of masking and lockdown that reduces
No,
flu,
that's
right?
public health measures. This is interference.
Yeah.
Like SARS-CoV-2 induces, let's say, an innate immune response that is inhibitory to productive flu infection.
What are your thoughts on China's zero COVID policy?
Not sustainable.
We were asked this last week. Can't be sustained. You need to vaccinate as many people as you can. How to attend our meeting in Nebraska? I'll let you know. I'm arriving on the afternoon, and we have some time. We could go have a tea or something. So I'll let you and Doug know.
It's next month.
Yep. Frank says, hello, Frank. I read about a new COVID drug called sabizabulin. Do you know anything about it? Do you know anything
Is that the
about
sour
it?
cherry drug? Or is that might be the microtubule inhibitor?
It's an orally available, binds to the colchicine binding site of tubulin and inhibits tubulin polymerization. They've tried this. Colchicine-like agents may therefore be useful in treating the cytokine storm. So this would be not a direct-acting antiviral.
I don't know how it's. So are they thinking it prevents vesicle trafficking within the cell and then fusion at the cell membrane?
They're thinking, cell migration, cytokine release, and intracellular trafficking. Yep. So has this been tried? It's in phase 3. Wow. Sabizabulin for the treatment of hospitalized moderate to severe COVID patients at high risk for ARDS.
Wonder how many side effects there are in the nervous system.
Yeah, that's an interesting point. Yeah, you would expect it might have a bunch, right?
Yep.
So anyway,
it's not clear how synaptic transmission would occur in reuptake of like serotonin and stuff.
Yeah, well, we'll see what the phase 3 results are, Frank. We'll see if it works to alleviate inflammation. What is your view now as regards the longevity of the pandemic/epidemic? Amy, what's your view?
Well, a pandemic and an epidemic are two very different things.
So what is your view on the pandemic longevity?
Well, what does that mean? When it's going to be over?
Yep.
As I said, somewhere in 2024.
2024. Okie dokie. Let's see. Where are we? I'm confused about the meaning of vaccine effectiveness. If the vaccine is 90% effective, does that mean I have a 10% chance of severe disease if I am 3 times vaccinated? I think what it means is that you have a 10% risk reduction, right?
I don't think that that's what it means.
What do you think it means?
I think there's a lot more complex math than just a straight extrapolation of that.
Well, 90% efficacy is usually 10% risk reduction. Means that the proportion of infection in a vaccinated group is 1/10 the proportion in the placebo group. 10% risk reduction. So that's the way to look at it. Risk reduction, not your likelihood of getting severe disease. And you do point out severe disease is what you're talking about, which is good. Can too many Omicron subvariants confuse the vaccine?
It's not like the vaccine is thinking.
No, not at all. I don't know what you mean by confuse. Do you mean the antibodies induced by the vaccine do not neutralize? Well, I don't know what you mean by confused, because viruses don't think, as Amy said. Mark says, my mother, who's in Shanghai, says they are quarantining symptomatic and asymptomatic people together. Does this make sense?
Well, if you're PCR positive, sure. Doesn't make a difference.
They're both infected, presumably, right?
Yeah, I would assume.
Any comments on B4 and B5?
As Paul Binoche said today, it's genius nomenclature.
Who are the geniuses that are doing this? The WHO?
I don't know. I just quoted his tweet. I don't have any idea who he's referring to.
67 years ago, IPV.
Oh. Yeah, he's right. I forgot to subtract the one.
Is long COVID more common with older people? Women more than men? What do you think, Amy?
I would have thought it was more common in younger people, and I have no idea if there's a sex different way.
Some studies have shown that women seem to be more affected. But as far as age, I think anyone can get long COVID, right, at any age, correct?
I think so, but I thought it was still more significantly reported in younger people. But I don't really know.
There's a paper here in PLOS Pathogens on the age dependency. But it's not easily coming to the fore. All right, so it's certainly more prevalent in women, but I don't know about the age. Any new antiviral drugs for COVID coming up soon? Well, you should listen to the next TWIV to drop tonight, because we had Richard Plemper on, and he talked about some, not all, but he's involved in some. He was involved in the development of the oral remdesivir, and he said it's in a clinical trial at the moment. So he thinks that will eventually make it.
Well, the science paper wasn't glowing.
Was it a science paper? Yeah, I guess
yeah,
so.
You did it on TWIV. Wasn't we did it with Dixon and Rich, I think. Wasn't like spectacularly.
It worked. That was the point. It worked, but yeah, need to be tested in people. Is there any bad news? No, there's no bad news, right?
No, there's no news. Do you have any news?
No, I have news, but I can't tell it.
How do you have news? What is your news?
I'm not going to tell it. It's not my news, actually. It's your news, but I'm not going to tell it.
Well, I don't have any news.
Okay, well, okay, you can say that, but I was worried about you, Amy, and Vince, since you take the trains. I'm glad you're on YouTube safely. Yeah, we're good. A lot of police activity around Penn Station this morning.
Yes, there was a lot of police around all last night since I went to Broadway last night. Yeah.
Rackham Hall, beautiful building, defended dissertation there. How cool. That's neat. Very nice. I'll be down in Westchester, New York, April 21st to the 6th with my 88-year-old mother who's coming up from Florida. How's the virus doing down there? Obviously, you guys look fine. But has there been a little blip up in the last week, Amy?
There's been a blip up for the last couple of weeks, yeah.
But it's still quite low. At Columbia, we returned to masking in classrooms because I think their sewage positivity rate went up or something. Isn't that what he said in the email? He just said positivity.
I don't know. I didn't really read the email. I consider it a 2,000-word spam.
Peter said, any good news?
Okay, so let's get this straight. I have no news, but yet I'm pregnant. or I was hired for that position. She got offered a position, but she's still considering it. When can we announce Amy's new position? I want
Ask
to know
Amy.
when my kid is going to be bored.
You're not pregnant, are you? No, you're not. You would have told me, no? You're not.
Well, it would be news to me.
Well,
That would be news to me.
people are interested to know if you have news about a position. And when you're ready, you can tell them, okay? Why don't you just say that, because you're kind of hanging them
I'm
from.
not hanging them. I've never talked about it.
Yeah, we've mentioned it, yeah.
Okay, whatever.
All right, Doreen
Philly
says,
went back to masking too.
reporting from my, well, in New York, you don't have to mask elsewhere. It's just, all I know is Columbia. But as soon as I get off the train, everybody unmasks. My building, no masking. Restaurants, no masking. Doreen says,
Actually, that's not true. I went to Broadway last night and everybody had to mask.
yeah, mask. Broadway has always been masked, but restaurants, you talking
Well, how
about a
would you
show?
eat?
A show or a restaurant? No, if I go to get bagels, nobody has masks on. It's not required anymore. Doreen is reporting for my weekly knowledge injections. Excellent. Multiple injections. Women who get long COVID outnumber men by 4 to 1. Thank you, Gribbler. My wife is a children's librarian in a major U.S. city. They are restarting toddler story time soon. She's vaxxed, but masks and vax are optional for kids and parents. Should she mask? She's 3x vaxxed. No need to. Up until this week, I taught in a Columbia class. Of course, they're all vaccinated, not like toddlers. So, but no, you don't need to mask. You'll be good. My mother in China sends her love and thanks. Well, thank you, Mom in Shanghai. Appreciate it.
It's lovely.
Demon Bunny says, if I had a bucket list, it'd include seeing Amy's lab. I bought my son a microscope, but really want to see a virus now with my own eyes.
No seeing virus even with microscope unless it's electron microscope. Can see bacteria, can see plaques that virus forms, but cannot see virus.
Yeah, you cannot see. It's like the lady from CNN who came in the lab and wanted to see us destroying a norovirus. Do you remember
that? We
that?
don't work on norovirus.
I had Ashley spray the counter with bleach and wipe it down. I said, she's destroying any norovirus that would be there. Were you around then?
No.
And I said, no, you can't. And she said, I did get an A in biology in college.
Yeah, she might want to give it back.
Give back the A?
Mm-hmm.
Well, Demon, you can see Amy's lab. She's going to have a lab for many years, so you can see it. Vincent and Amy, future vaccines, what do they need to prolong protection? Memory. They need to induce good B and T cell memory. And at least for influenza, apparently that requires an adjuvant. But
in theory, I'm not clear that his hypothesis has been proven.
Yeah, it's only his paper. But it may be that the mRNA vaccines are particularly good at inducing memory. We'll see. And then that could be broadly applicable. But wouldn't it be fair to say, Amy, that the qualities that confer memory are really not understood?
Yes, that's why I just said I don't think that Rafi's paper actually says directly that an adjuvant confers memory. I think he suggests it, but he does not actually prove it. He says that's one reason why the flu vaccine in Europe might be better. But it turns out that John Wary at Penn has a paper showing that I think that immunity lasts 18 months.
What do you mean immunity? Memory?
Yeah, memory so far is lasting 18 months.
And we don't know longer because we haven't looked longer, right?
Well, you can only look as long as the people who first got vaccinated. You can't look
Yeah.
5 years, say it lasts 5 years if the people weren't vaccinated 5 years ago. That would be ridiculous.
Yes, indeed. All right, that was EN. Who is next? Ralph Barrick doesn't give interviews to anyone else, so humanity is deprived of his commentary if he doesn't come on TWIV. Okay. We'll get him back at some point, but I'm not sure what he would say right now. People are going on about the released Pfizer papers. Any thoughts? I'm sorry, I never looked at them. And if I can't do it right now. I have some other fish to fry. My apologies. I did say I would look at them, and I apologize for not looking at them. Thoughts on the Tuskegee syphilis study? Why is this coming up? It was terrible, right? For them to carry
Yeah,
out.
it was a horrible thing. Most people think it didn't last. Do you know when it actually ended?
No.
It ended in like 1972.
When did it start?
In like 1920.
Horrible. Absolutely horrible. Which is not something that should be done anymore. It should never have happened, but that's so much for medical ethics. Yeah, it's horrible.
Yes.
Are there theoretically some small percent of people who have immunity against C19, as in other previous diseases in the ancient past, that killed up to 90 to 95% of humans?
What?
All right, so I don't know what outbreaks killed 95% of humans, but he's saying that maybe the 5% who didn't die had some immunity to this novel pathogen. So is that, there's no evidence for that. I mean, there's some cross-reactive immunity to common cold coronas, right, Amy, and SARS-1, but we have no idea whether that plays any role in protection of any sort.
No, but
So,
I don't even know why we would go there. I think it's just very simple. So for instance, there are many people who who have had multiple exposures to chickenpox and have never developed chickenpox.
mm-hmm.
Right? It's not really clear why they haven't developed chickenpox, even if they lived in a house where all their siblings developed chickenpox.
Yeah, they probably have a genetic
Yeah,
marker that makes
exactly.
them
I don't know that
resistant.
it's
Yeah.
immunity or if it's something else. Maybe the receptor for the virus is wonky in them.
So let me just say one thing about influenza virus. I agree, it's likely to be genetic basis. To explain, like elite controllers who never develop AIDS, they have certain HLA types that protect them.
They
Influenza,
also have
though,
CXCR5 deletions.
not in elite controllers. No, elite controllers have certain HLA
Well,
types.
there are people who have CXCR5
Yeah, well, they
deletions or
never get
whatever.
infected. They don't get infected. Elite controllers have low-level RNA for many years. If you have a CCR5 deletion, you don't do that. But influenza, if you lived in 1918 and recovered and had immunity, then in 2009, because that virus was related to the 1918 virus, those people didn't get sick. So in some cases, immunity can help you. What do you think of the theory that COVID precautions have resulted in an increase in flu in children because they didn't acquire usual immunity? Has there been an increase in kids, Amy, in
In
influenza?
flu? Not that's been reported that I know of.
Remember, during that lockdown time, there was very little influenza, right?
Mm-hmm.
And now we're seeing rises. We saw a rise this past season, which is nothing out of the ordinary. In fact, I think the levels are lower than usual. By the way, last week you folks asked about how the vaccine match was going, and I erroneously said it was pretty good. And so on Friday's TWIV, we explained the actual situation, that there is a mismatch with the H3N2 component.
Yeah, you're going to have Scott come and talk about it.
Yeah, Scott Hensley, who or Henley, has a paper in the works about it, and when that's out, we'll have him on. Yeah. Dr. Campbell says protection from 2 doses is fading fast. Is he right? Protection
No.
against what? What? What does he say? Does he actually say protection against what, or does he just say protection is fading fast? But anyway, it's not. If you say severe disease and death, it's not fading fast. He's just wrong. Have you read today's Offit editorial in New England Journal on boosters? Have you read it, Amy?
No.
So it's basically saying the situation is confused.
Oh, you read it?
Well, I have it right here. It's quite short. And he's saying
Oh.
the CDC is giving a mixed message. Who should get the boosters? And he says, it's based on the Israeli study. What about, okay, older people? The FDA is considered for older people. What about younger people? So he says the studies did not stratify patients according to age or coexisting conditions. So he says that we're having mixed messages and people are confused about what it means to be fully vaccinated. The most disappointing error surrounding the use of COVID vaccines was the labeling of mild illness or asymptomatic infections after vaccination as breakthroughs. The term breakthrough, which implies failure, created unrealistic expectations and led to the adoption of a zero-tolerance strategy. Sounds similar to what we've been saying, right, Amy?
Yes, except for the fact I don't believe that it was the word breakthrough. I believe it was the Israeli study that said, oh, look, 7 days and you're protected against transmission and infection. I don't consider that a breakthrough infection.
Anyway, so Paul is always right on. It's really, we agree. I had the Pfizer booster December 15th. When should I have the next one? If I should have it.
No need.
There's no need to have a second booster, in our opinion. Are there any situations, Amy, where one might consider a second booster? Like if you're 95 years old?
Well, my stepfather is 93 and I was not advocating a second booster.
Okay.
I mean, it's 4 weeks. It's additional. It's only 4 weeks of high antibody titer, and who knows what high antibody titer means. So, what's the
Yes.
logic? It's not clear to me.
And, our listeners have got it. Protection against what? Infection, serious illness, and death. Perfect. Perfect.
How about
Okay.
stupidity?
Do you think the lipids in the mRNA vaccines have more to do with the effectiveness than the dosage of the mRNA?
The IL-1 paper.
It says 2 signals, right? One is RNA and one is lipid.
Mm-hmm.
So I think they're both important. And one of the messages from the IL-1 paper, which we did 2 Fridays ago on Twiv, is that right, Amy?
It was not on it. It was a Tuesday.
It was a Tuesday. Is that we can't give as much dosage as we'd like because that might improve T cell responses because it stimulates too much inflammation, and so people want to deal with that. All right, if you have a range of different cells that are suitable for use in plaque assay for a particular virus, how much variation in number of plaques for the same dilution of virus might you find? That's a good question. There certainly is variation. I recall some viruses that we have used in different cells give very different plaquing efficiencies in different cell lines. You recall offhand any of that?
Yeah, so
Amy?
like EBD68, some EBD68s can plaque on HeLas, and you get like a 3 log difference compared to what you get off of RDs.
Oh, so it can be 1,000-fold difference in titer, right?
Mm-hmm.
Yep. So there you go, Doug. So Sally is back to the more dangerous, and she's saying maybe more able to evade immunological measures. And Amy would agree with you because she says you had the boost to take care of that. So if you say,
Well,
yeah,
yeah. You don't have to agree with me. I'm just saying that you can't walk both sides of the street. You can't
oh,
say that
yeah,
it was not more dangerous and then say you needed a booster to protect yourself. So,
well,
obviously,
I have always contended it's not clear that we needed that second booster. There's some
you've
studies that say you
advocated
didn't.
it. You've advocated
Yeah,
it
I've
since
advocated it
since the paper.
based on
Since that
the
paper from
neutralization.
Quebec,
Yep.
since the paper from Quebec, you've advocated it. So therefore, by advocating, you are saying you need the booster.
I'm not looking at it in terms of more dangerous though, because if a vaccine can handle it, it's not more dangerous.
But the vaccine couldn't handle it. That's why you needed the booster.
It did. It's the
That's
same
the whole
vaccine.
point. That's
Just
the
gave
whole
another
point.
shot.
No, it's not the same.
No, no, no.
It's a different. It's a
Remember,
different number of vaccines.
the first two doses
So,
were erroneously too closely spaced, so the vaccine
oh,
wasn't able to
really?
work.
Shit from every one of them was correct.
Who's that? You?
Yeah, and I took shit from you and from various other people.
No, I agreed with you on the
No,
booster,
you
on
didn't.
the dosage
You
wrong.
didn't agree with me. We
I
can go
did.
back to 2 years ago where you didn't agree with me because you were citing Brian as the immunological genius. So you didn't agree with me. So let's not rewrite history. Let's just tell it the way it was. And
I agreed
then
with you on the timing. You can go back in TWIVs. We can find it. It's not worth it, but I agreed with you.
well, no, you didn't, but that's okay.
But Amy, isn't science a matter of agreeing and disagreeing? Why does it have to get personal?
It's not personal until
Well,
you
it sounds
start
like
to.
you're making it personal. That's all.
No, it's not personal. It's the fact that you don't own up to the fact that you were wrong. And then and then up until that paper from the people in Quebec, you saw the light. And then
What
you
was
want
I
to say
wrong
that the
about?
virus.
All right. Look, let's answer people's questions, not argue with each other.
It's not an argument. It's just a correction. A correction is not an argument.
I have never had a problem with being corrected. I don't know
Yeah,
why you
you
say I
do.
do. No, I don't.
Everybody does.
I don't
Everybody
have a
has a
problem.
problem with being corrected, and then the people write in and say that we're cantankerous to each other. And the fact is that if you didn't take it personal, like when people said you, and you didn't understand that there's a plural form of you, it wouldn't become, people wouldn't write in and ask us, why are you cantankerous towards each other? And then I wouldn't be told that I'm arrogant and I'm mean to you.
Would a fourth shot prevent symptomatic infection?
No.
A fourth shot will give you a boost in antibodies and T cells for a short period. Then it will go down and you will get infected. You can get an asymptomatic infection. You can get a symptomatic infection, but you most likely will not have severe disease and death. But you don't need a fourth booster for that. Can you explain what Dr. Griffin was talking about? A home kit with antiviral kit. Oh, right. There's a kit where it combines a test and then a drug. And I don't remember what the drug was, but if the test is positive.
It was like for flu. It's like
Did it have
Thermoflu.
Tamiflu in it?
Yeah.
Yeah, and he said it's Bluetooth controlled. So if your test is positive, then it opens up the box and you can take your antiviral, your Tamiflu or whatever. What do you think about that, Amy?
This is interesting.
Regarding China's severe lockdown, can we wonder if some of the Sinopharm data might not be very truthful, or is it just bad policy?
It's just bad policy.
Yeah, I mean, I would assume they're being truthful with the data, right? It's science, so I may be naive, but yeah, I think it's bad policy. They should be enforcing immunization, and you can't lock down at this point. It's just not going to work.
Why did you qualify it?
How do they qualify it?
It's just science, and I presume that they're being truthful.
It's not qualified. That's what I'm thinking. It's science. The scientists are reporting the data. I believe they're being truthful. How is it possible to transmit enough virus to infect another person when asymptomatic? Are people really asymptomatic or just ignoring their symptoms? Does this happen in other diseases? So, yes, you can still shed enough virus to infect another person when you're asymptomatic. So, symptomatology is not always related to the quantity of infectious virus that you're shedding.
Well, it's not
So,
related at all if you're vaccinated or you had prior infection,
yeah.
because the symptoms correlate with the immune response, which is prior to when you shed infection, which is why people started coming out and saying, oh, look, you get symptoms earlier, so the virus is replicating earlier or faster. Remember that?
Mm-hmm. This was a whole thing a while ago. People say, how could you transmit if you're not feeling something? But yeah, as Amy said, much of the symptoms are immune based. So virus is reproducing away. And yes,
And
it
lots of
happens with,
people,
go ahead.
go ahead. Go
It
ahead.
happens with other viruses as well. Not all. So with Ebola virus, you don't transmit until you're symptomatic. So it's different depending on the virus.
Yeah, but measles is classically you transmit prior to the
Yeah.
onset of the rash.
Same with flu. You transmit a day or so before onset of symptoms.
And
So
chickenpox, I believe, is the same thing, that you
exactly.
transmit before the onset of pox.
So these infections where you transmit before symptoms, obviously they're problems because people are out and about and shedding and transmitting. When will more comfortable masks and other PPE be produced? Oh, you talked to Amy about a BSL-3 mask, right?
Yeah, it's not so comfortable.
I don't know, Ian. I have no insight into that. I think the problem is when you put something over your nose and mouth, it's inherently uncomfortable, right? So I'm not sure it can get much better. I come out of the subway, and sometimes walking up a couple of sets of steps, I get, out of breath, and it doesn't help to have a mask on. Take it off, and you can breathe much better. So I don't know.
Okay, it's 9:17, like 2 more, and then I have to go.
It's anecdotal, not scientific evidence, but most people I know are triple vaxxed, and most of us have now tested positive. Yes, with varying degrees of symptoms. Yes, but how many people do you know have died who are triple vaxxed? Probably very few. So that supports what we've been saying here, right, Amy?
Yes. So my problem is that there's still a lot of confusion about what vaccines do and whether or not it's acceptable to have mild symptoms. And so I think that this is a problem.
I think it's fine to have mild symptoms, isn't it?
Yeah, but people are have this belief that you don't get infected and that if you have mild symptoms you're going to die, or if
Hmm.
you have a positive test you're on the path to dying.
Right. Um, colchicine binding site. Do you want to say what a colchicine binding site is, Amy? Colchicine is a drug, right?
Yeah, it prevents the polymerization, the addition of a tubulin monomer, right?
Yes. So, but colchicine prevents the formation of tubules within cells that allow cells to move, allow things within cells to move, and so um, they would depolymerize the tubulin.
Does it depolymerize or it just prevents
Prevent.
polymerization? Because
Yeah.
depolymerization is a different action.
Yeah.
It's where you remove something.
The article I was reading compared it to nacatazole, which, as you know, depolymerizes. So, but you're right; it should prevent polymerization.
Yeah, and they're not equivalent. They're not the equivalent action. So the microtubule doesn't grow or shrink, it just stays the same. Whereas I believe nicotazole triggers the loss of a monomer, but I could be wrong.
Correct. Amy, why do you question that Montreal has the best bagels?
I thought that they were a little sweet for my taste, um, and stuff, but other people like them. It's just like other people like them when they're lighter and stuff. So that's just it. I think they have more. I think they have honey or sugar in the dough, and I'm not sure that like a New York bagel has honey and sugar in the dough. If I remember correctly, they don't. But it's just a preference.
Any opinion on Tempol? This is
I
that
don't know
drug.
what it is.
This is the antiviral from NIH that's a polymerase inhibitor. And I think it has been in animals only. Has it been published? Yeah, it's yeah, iron sulfur cofactors in SARS-CoV-2 RNA-dependent RNA polymerase are antiviral targets. That's a science paper, so apparently this does something with that.
And
Tempo
it's better than
it can degrade iron sulfur clusters.
and that's used for the polymerase.
It's a polymerase inhibitor. Yeah, apparently that kind of those are cofactors for the polymerase. Yeah, it's a science article.
It's better than molnupiravir and other analogs or chain terminators, whatever.
I don't know if we can say it's better at this point. It's an alternative. Plemper said the more antivirals, the better.
That's true. We've always advocated for combination therapy.
Damon said, I really want to try these New York bagels and some of those cream cheeses Vincent showed last week. Don't tell Amy you're going to try those cream cheeses.
I have no problem. They can try them.
But you would never touch them, right?
I'm not a big fan of cream cheese to begin with. And I'm not a big fan of cream cheese or chocolate on bagels. I'm not a big fan. People can have avocado cream cheese. I'm fine with that. I'm not a big fan.
I tested positive for 5 days on LFT, then showed a faint line for 3 days. It's now dark red again on day 9. How is that possible, please?
Is LFT a rapid test and then I have to go?
Lateral flow. Assume rapid antigen, most likely.
Yeah.
I think it's probably been positive for all these times, and the faint was some kind of an error. But if
Well,
you're
it
now,
also.
Go ahead.
No, go ahead.
If you're positive again, it's not like you got reinfected. It's a continuing infection, and the ones in the middle were just not correct.
Yeah, probably you didn't take the sample properly. It's usually user error.
All right, one more. Let us know when you come to D.C. and other cities so we can meet you and buy you a beer. So I'll be in D.C. in June for the ASM meeting.
Yes, a twin.
Yeah, and he said I could have a room and record other podcasts if I want.
Well, that's great. Do you know any of the? Did we look at the virology panel?
You know, it's very thin, as usual at ASM. But
did we look at the parasite panel?
No, think I should do a TWIP. I gotta have one of the TWIPers with me, though. I can't do it alone.
Or, yeah, I mean, is there an evolutionist? Would you do it? Well, I guess you wouldn't do TWIVA without Nels either.
No. So ASM is June 9th through 13th in Washington, D.C. I'll be there. And if you want to meet up, let me know. I'll be happy to play hooky and meet you instead of going to the meeting.
Since when?
And now Damon says, I am 100% making decisions based on what Amy thinks now. All right.
That's a little scary. I'm not sure I'm an advocate of that.
Mitchell says Montreal bagels are the Shemp of bagels. They're terrible, too sweet. Yeah, Amy, there you go.
Everybody likes something different. They just were, and I didn't feel that they had as thick a crust. I like a more crusty bagel. I think that that's so like, even though like we had them warm from the place down underneath where you are, uh they needed like they're good, but they need a little bit of a thicker crust. But that's just a personal thing. You know, not everybody likes crusty bagels.
The ones at the bagel store below the incubator, were those considered crusty?
Yeah, but they need a little thicker.
You need to go, Amy?
Yeah, I need to go plate out some cells, and then
All
I
right.
need to go move some boxes.
All right, Amy,
All right.
thank you.
I'll talk to you tomorrow or Friday.
Okay. Bye-bye.
Bye.
Let's get that out of there. Okay. Why predicting COVID over in 2024? You mean, so I don't understand what you want to know. Is it too short? You think it would go longer? Is it too long? Well, pandemics end, right? 1918 flu pandemic ended eventually without any vaccines or antivirals. Eventually, the big waves of infections, or I should say severe disease, go away, probably because of population immunity. So that's what will happen. But the virus isn't going anywhere. It's going to stay. It's going to infect people every winter. And if we decide to test, we'll see it. But we don't do much, random testing for flu. We test people who have symptoms to see if we should give them an antiviral. But we don't do the random testing that we're doing here. So we don't see it. But I'm sure if we did, we'd see waves and waves of flu. But that's what will happen with SARS-CoV-2. But most people will not have severe illness any longer as a consequence of immunity from either infection or vaccination, right? Just another virus in the human catalog. Do we know more about how much damage mild COVID infection causes yet? So, no, we don't. This is a problem because it's hard to, first of all, we're not that far out from COVID, right? So we don't know how long damage lasts, long COVID, if you will. Many of the symptomatology screens, they're questionnaire based, right? And so they have a certain amount of inaccuracy. I saw one recently of kids looking for long COVID, and they had 8 symptoms, and they said 95% of the kids had 4 of the 8. I mean, I don't understand what's going on, and maybe it's a bit confounding. I don't dispute that there's some people with persistent symptoms, but I don't understand how it could be so frequent. And whether mild infection does this or not, to me, it doesn't make a lot of sense. Now, I realize that you can have long COVID after a mild infection, but why would that happen? I don't understand, unless it's an autoimmune phenomenon. So I think we're still in early days with respect to this question, how much damage. I think that drives a lot of fear in people, that they're going to have some damage that lasts forever. I don't see the evidence for that yet, and I know that you might not want to wait and just be careful. That's your prerogative, but I don't see the need to do that. What are the chances that SARS-CoV-2 makes a copy mistake and mutates itself out of existence? Does that happen with viruses? So, no, viruses make mutations all the time, and when there's a lethal one, that particular virus is gone. But there are many more viruses that don't have that mutation. So when a virus infects a cell, it reproduces its RNA, right? And it makes mistakes at every copying. So it takes one RNA, makes another, and then another, and another, and it makes mistakes. But there are always copies without lethal mistakes. So you would never have one lethal mutation in all the copies. That's not the way it works, because they're random mutations. So when mutations happen, which they do all the time, some of them are lethal and we never see those genomes. But there's still plenty of genomes with neutral mutations, and occasionally there are genomes with mutations that benefit the virus, like Omicron, and they get selected because they evade antibodies, for example. So the answer is no. A virus will never mutate itself out of existence. Oh, well, Rima's in Lebanon today. Cool. 3:50 a.m. Well, thank you for staying up. Appreciate it. EAN, are immune evasion and genetic drift of a pathogenic virus semantic equivalents? Without genetic drift, re-disease won't occur. Without evasion, disease after vaccine won't occur. All right, so genetic drift is the mechanism underlying antigenic change, which is basically immune evasion, right? So as an RNA genome replicates, it sustains mutations randomly, and these mutations may be in antigenic sites, and if they confer an advantage in the face of antibody, they can be selected for, and therefore they will predominate in a population because they're more fit. They are able to reproduce in the presence of the antibody, so they're more fit. So genetic drift is just a change that occurs on every reproduction cycle. The virus is changing slowly, and then immune evasion will happen when a variant is selected that evades antibody. So, and then you say without genetic drift, re-disease won't occur without evasion. So all viruses undergo genetic drift, and they also do antigenic drift, but it doesn't always matter. So for measles and polio virus, we do see antigenic drift, but the vaccines still work. We've been using the same vaccines, the polio vaccine for 67 years, the measles vaccine since 1962. So for some viruses, it's not enough drift to cause a change that would evade vaccination-induced antibodies. But I mean, if you didn't have a measles vaccine, you would have people getting infected, and then they'd become immune and they wouldn't get infected again if they survived. But then new kids would be born who are not immune, and they would get infected. So you always have a continuous supply. So you don't need genetic variation to infect them. But that's not the way it works for all viruses, right? Influenza viruses do antigenic drift. So does HIV. So does SARS-CoV-2. So it's different depending on the virus. What is happening with clinical trials for infants, young children? Why is it taking so much longer? I don't know. Daniel always says he doesn't have a reason. He doesn't know either because he's not connected. So when he finds out, you'll find out. And since he has an update every week, that's a pretty good frequency for you to find out quickly. So the other issue that people are bringing up is, long COVID after vaccination. And there are some numbers, but I don't think they're good numbers because the studies need some improvement. So I think we need more work before we make any conclusions about incidence of long COVID in vaccinated people after mild infections and so forth. I know people are getting long COVID after mild infections, but how long is it really going to last? Is it 2 years and that's it, or is it longer? And if it's over in 2 years, what's the significance? What fraction? We just don't know the answers to these questions. So to make a blanket statement that millions of people with mild infections are getting long COVID is not really giving the whole story because it hasn't been that long. Okay, in the course of a 2-week infection, it's long. That's why it's called long COVID, because normal COVID is over in 2 weeks. But we don't know how long it is. There was a virus going around. Papa caught it, and he died last spring. And now Mama doesn't seem to want to do much of anything. Yeah, I know that song. But I can't tell you what it is. I'm not good with naming songs. Sorry. I never listened to enough music in my life. Unfortunately, because it's fun. I put 2 speakers in the incubator so I can listen to while I'm editing instead of always listening in a headset, I can listen to the sound on speakers because some people listen that way. And so I was playing some music the other day, Pink Floyd, just for 5 minutes. It was very comforting, but I can't work that way. So I don't listen to a lot of music. Anyway, I don't know what the name of the song is. What is it? Tallahatchie Bridge. No, it's not Tallahatchie Bridge, is it? Tallahatchie Bridge, the guy from New Zealand. Ode to Billy Joe. Yeah. Tallahatchie Bridge. Wow. I didn't know you had music in New Zealand. That's a joke. Okay. Did the 1918 pandemic end with people gradually just going back to normal life? With this pandemic, should places with 80 to 90% vaccination rate just return to normal? Yes, for 1918, life gradually went back to normal, right? The waves got fewer and shorter and so forth, and eventually it just became endemic. Every winter there was flu. 1918 virus stayed around, and it slowly drifted. So it could reinfect, even though you had survived the 1918. So I think, yes, if you have 80 to 90% immunization by vaccination or infection, yes, you should go back to normal. Now, people will say, but what about long COVID? You got to make your own decision if you're worried about having mild disease in a vaccinated scenario, getting long COVID. I know people say it happens. It doesn't make a lot of sense to me, but I'm not going to let that stop me. But you can continue to mask and be careful. It's fine. But I think if I were doing public policy, I would say get back to normal. So, in March, we got rid of masks at Columbia in classrooms. And now this week, suddenly, we're masking again. That makes zero sense. Just because the positivity rate is going up slightly, it's because we're checking so much. Flu positivity rate goes up in different periods in the winter. We don't do anything about that. And yet 40,000 people can die of flu. Now, there's no long flu, okay, but it's an unknown. This is what we have. How long are you going to wait for them to figure out long COVID and relationship to mild disease? You want to wait 5 to 10 years, which is probably what it will take? No, I don't think so. At some point, you got to get beyond the science and just say, this is what we have, this is the vaccine we have, this is what it does. There's a potential for long COVID, but you cannot keep living locked down or in some semblance of lockdown. It's my opinion. And I've seen this and thought about it a lot. Well, Amy's not here. You're still masking. So Amy doesn't mask on the street. She doesn't mask on the lab. She doesn't have to. You have to mask on the subway. It's crowded there, but that's a law. And she goes to a health club. I don't know if she masks at the health club, if it's required or not. It might not be. So, but next time you should ask her. If someone tests positive on an antigen test, how long will they continue to test positive? So people have reported testing positive for 10 days, 14 days. It should be 7 to 10 days. And you could be, what governs that is just not clear. But people can shed protein well after you're contagious. So you're not shedding enough virus, yet you can be still positive on the antigen test. The antigen tests have turned out to be a little strange in that sense because we thought they would correlate very well with the infectious virus. And for the most part, they do. But then there are these long positivity things that we don't understand. I think the suggestion is that you're not infectious during that period. You can't be, because if you have a normal COVID course, you're not shedding. 14 days, you should be way down in shedding. And so then K-Band says if an antigen test is positive, how isn't that mean you're infectious? How can you have viral proteins? Well, you can have broken virus particles, right? Or you can have infected cells that are breaking open and releasing viral proteins that have not been built into infectious virus particles. Okay, so the idea that the presence of a viral protein indicates infectivity is not correct. Just like PCR positivity doesn't mean that there's an infectious virus present. Why do they call Omicron a stealth variant? I mean, because in many places it spread very quickly, and the idea was it wasn't causing a lot of disease, right? So silent spread, stealth, without knowing it, but it does cause disease. Everyone who's died in the last few months has died of Omicron, so it's not a stealth variant. And I don't even like it when Daniel calls it a stealth variant, because it's not a stealth variant. But, the way it is, when a word gets used and established, you can't get rid of it. Apparently, long COVID tends to spare the very young and the very old. Okay, some benefit of being old, huh? And young is always a benefit because you have your whole life ahead of you. If you were vaccinated at age 70, would your risk at age 80 increase to the same level as someone who was vaccinated at age 80? Or do you carry more protection from being vaccinated at a younger age? No. You get vaccinated at a young age, it wanes, it contracts as you get older. You have turnover of memory cells. But if you are vaccinated at an older age, you don't respond as well because you're unable to make new, for example, T cells. So if you're vaccinated at 70, your protection will decrease. You have turnover of memory cells. And if you're vaccinated at 80, you'll have less protection than you had at 70. But whether they're equivalent, I don't think we can say that. No. Everybody wants to know about Amy's position. You're going to have to get it from her. So I know the answer, but I'm not telling you because it's her, and she doesn't want to say it, so you got to get it from her. What Broadway show did you see? You talking about Amy or me? I don't know, but I saw a show in December. I saw Moulin Rouge. Fantastic. What are your thoughts on COVID vaccine booster potential for causing original antigenic sin and immune deficiency? I don't think there's no evidence for original antigenic sin. Let's define original antigenic sin. I'm going to even look it up because I have my own definition, but you know how definitions, your first exposure to an antigen defines your response for the rest of your life. The term original antigenic sin first used in the 60s to describe how one's first exposure to flu shapes the outcome of subsequent exposures to antigenically related strains. All right, so it's coined by Thomas Francis, a very well-known virologist, and what he found was that antibody titers were highest against seasonal influenza strains to which specific age cohorts had first been exposed. And it was subsequently confirmed in other experiments. So he suggested that you get infected with a virus, your first influenza exposure, and then subsequent infections with similar virus strains preferentially boost the response against the original strain. Okay? And so for flu, you make a variant vaccine, and then if your first exposure was a different, let's say an H1N1, you're making a preferential response to the first H1N1 that you saw. So that's original antigenic sin. And, in context of flu, it's not great because you don't want to make a preferential response to the ancestral H1N1. You want to make a response to the one that's circulating for which you are vaccinating. And that's the problem with influenza virus. So do I see any of that for SARS-CoV-2? So we're all immunized against ancestral spike, pretty much, right? Except if you've got an activated vaccine. Most of the vaccines are spike-based. Most of them are ancestral. The original isolate back in the beginning of 2020, for example. So you get that, and then you get infected, say, with Omicron. We haven't changed the vaccine yet, so there's no original antigenic sin to talk about, right? When we make a variant-specific vaccine, if we ever do that, and it turns out that you mostly respond against ancestral SARS-CoV-2, then that's antigenic sin, original antigenic sin. But there's no context for it right now, okay? That's my thought. You asked for my thoughts. You got them. Philadelphia's going back to masking. Why? Ay, ay, ay. So Gribbler says it's stealth because it can return a positive PCR that is looking for Delta. All right. I don't like the name. Don't like the name. Yeah, it's right. It was nicknamed Stealth BA2 when it was difficult to track it in PCR tests. Right. Thank you very much, Gribbler. And I do admit when I'm wrong. Amy is not pregnant. No. Guys are talking about naming babies. No. No. She's not pregnant. From Twiv887. Oh, that's just last week. When the vaccine was shown to have a beneficial effect on antibodies other than the inducing antibodies, did Amy say you think? Probably. I don't remember. Do your classrooms have windows that can be opened with screens to have fresh filtered air? Not the classroom that I'm in currently. They vary. I need a big classroom because I have over 100 people. And some of them have windows. I remember there was one classroom in the physics building, which was really big, and they had windows in the back. And sometimes students would open them because it got hot. And there was another classroom I had, but others do not have windows. So this year we don't have windows. No. I'm triple vaxxed and recently got infected, more like a little cold. That's the idea. That's what the vaccine is going to do. Sorry for the confusion. This was about the infectivity shedding. I just meant the same log FFU per mil at the same day, post-symptom onset between vaccinated and unvaccinated. Yeah, I think that's correct because because Omicron is not being neutralized, right? So you're not impacting virus shedding. Whereas if you get the third dose, the booster, then it neutralizes. But remember, this is shortly after boosting. Yeah, so it's going to be different 6 months later when there's no blockage of infection, at least initially. Why wouldn't one mask just to be cautious? I am 3 times vaccinated, have a 4-year-old and mask in public all the time, regardless of whether you can do it if you want. I don't want to. I don't feel there's any need to. Here in the U.S., we have not historically masked extensively. And I feel that scientifically we're at the point where we don't need to. We have vaccines that work. You get a cold, more or less. The issue with long COVID is unknown, and if you want to mask because of that, that's fine. You can be cautious, but by extension, I am not being uncautious. Okay, I feel that I, like many other people, are prepared to go out in the world maskless because of the vaccines. Can you please give us the explanation again about the difference between SARS-1, MERS, and SARS-2? 3 different epidemic human coronaviruses. So they caused outbreaks, spilled over from animals into humans. So before SARS-1, we had 3 common cold coronaviruses that were known for some years that caused mild upper respiratory tract illness. And then in 2003, an outbreak of novel severe pneumonia in the south of China, and it turned out to be caused from a virus that entered humans at a market in Guangzhou. And that virus came from palm civets that had been brought in from the countryside, and the palm civets had been infected in the countryside by bats and then brought into the market where they shed virus and infected people, and multiple spillovers. Now, we know this because the genetic components of SARS-1 was found in a cave in Yunnan province, which harbored bats with those viruses. Not any one virus that was the ancestor, but several that could have recombined to give exactly SARS-1. That outbreak ended after 8,000 cases. The reason it did is there's no community spread of SARS-1. SARS-1, the peak of shedding occurred at the peak of symptoms, and most of the time, over half of the time, people were in the hospital because it was quite severe. So it was very easy to limit spread in hospital. No community spread, so we stopped it after 8,000 cases. MERS coronavirus first recognized in 2012. Most of the cases in the Arabian Peninsula, some have been exported. But here is a case where camels pass the virus onto humans. And camels are infected as soon as they are born in a herd. They get a mild respiratory disease and they recover and become immune. But during the time that they're infected, they shed, and if people are near them, they can infect the people. But it's quite rare, and each spillover from a camel to a human never goes many chains of infection. They don't go very long, and eventually the infection peters out. And so then you have another spillover from camels, starting another infection. There are a couple every month, mainly in the Arabian Peninsula. High fatality rate, but the approach there is going to be to immunize the camels because there aren't enough human infections to justify vaccinating humans. And then, of course, SARS-2, these are all genetically different viruses. So SARS-1 and 2 bind ACE2 as a receptor. MERS coronaviruses binds a different protein, dipeptidyl peptidase. And they have other differences as well, and they cause slightly different diseases, but they're all respiratory diseases with a characteristic of an inflammatory phase that can cause severe lung injury. And so SARS-2 is different from both SARS-1 and MERS in that it spreads in a community fashion, which means it is shedding before symptoms, and many people have asymptomatic infections so that they spread the virus, whereas with MERS and SARS-1, that's not the case. Well, TWIVs are excellent, but I have to say every time Amy's on, I know it's going to be an excellent. Very good. I'm glad you like it. I was wondering who was speaking German here. Opinion on COVAX-1, a coronavirus vaccine designed to induce T-cell immunity. So COVAX-1 is a subunit vaccine it's a multi-peptide vaccine, and the peptides are based on T-cell epitopes. And so 6 peptides derived from different viral proteins are incorporated into this and then given as a subcutaneous infusion into the skin of the abdomen. And, they did a phase 1, and they saw T-cell responses to the peptides and so forth. But I don't think... So this is mainly being developed to prevent COVID in cancer patients who are immunosuppressed, right? So I don't think this is going to be a generally available vaccine. But, it could be that the principles learned might be applicable. I've been tweeting your way about immunologist A.J. Leonard's nice talk recently about T cells and how repeated infections may be causing early T cell senescence. What's the plan for mRNA vaccines for yearly flu vaccine, other virus? So all I know is that some flu vaccines mRNA vaccines are in trial. I don't. I know that I think Moderna is doing a flu, SARS-CoV-2, and respiratory syncytial virus combined mRNA vaccine. So there will be others in the works as well. So it's quite exciting, I think. I like to listen to Ralph because he has a greater picture. Yeah, I like Ralph. But, we can't have him all the time. You have to respect his need to do work. But when I feel that it's time to bring him back, we will. I just don't think, I think we got all his greater picture. And so I have to feel that there's something else to get. But I think as we wind down, that might be a good time to get him back. Assume the next pandemic is flu. It probably will be. We're due for one. What piece of advice would you give if you could wave a magic wand and get everyone to follow it? So the next flu pandemic, depending on when it is, we may be using mRNA vaccines, right? So I would say to get vaccinated, because that should take care of it. If we can get the vaccine out quickly enough, that's the problem, because it's a 6-month delay and then you have your first wave. I think it's all about vaccination. Have the 2022 influenza components been formulated? Yeah, I know that the H3N2 component is this variant that arose last year or 2020, and it's the one that's making the current vaccine a mismatch. So the WHO has recommended that be part of the 2022 flu vaccine. So H3N2 will change. I don't know about H1N1 and B. I don't think there have been any big changes there. I got into an argument over which virus mutates more, influenza or COVID. Which is it? I don't know what you mean by mutates. If you're talking about the intrinsic error rate of the polymerase, right? How many mistakes it makes every time it copies a nucleic acid molecule. The error rate for influenza will be higher because SARS-CoV-2 and coronaviruses have an error correcting protein that lowers the error frequency. So that's the lowest you can get in terms of mutation rate, the error rate of the polymerase. What you see coming up in people is the product of selection. And so that doesn't give you an indication of the error rate of the polymerase. And it depends on selection. So for both viruses, there's antibody selection that pulls variants out that may have an advantage. That's what gives us the flu variants every year. That's what has given us these variants of SARS-CoV-2. So I think they're likely to, well, right now it's hard to compare because SARS-CoV-2 is infecting so many more people, right? And so you're getting more selective forces. So apparent changes are greater, but it may be so today it's SARS-CoV-2, but it may be that when SARS-CoV-2 reaches its stasis point where, we don't think about it anymore, the two will have a similar mutation rate in terms of what amino acid changes eventually get selected. Hello, Tiffany. Thank you for your support. Traveling to Rome from the U.S., then taking a cruise to the Greek islands. We're all vaxxed and boosted. Boosters will be 4 months old a week before we leave. Thoughts on the second booster? So here's the thing. You could get infected, and you might have a mild disease, but it's inconvenient, right? Because someone's going to want to quarantine you in the middle of your trip. And so if you got a second booster, it would prevent you from getting infected. So that is one scenario that, and it's not going to last very long. It's going to last 6 months, and then that's it. So if you want to avoid that scenario, yeah, you can get it before you go. If it were me, I wouldn't do it, but because I'm willing to take my chance with a mild infection. Do you folks see a link between immunity and vitamin C? I don't see a link. Many studies have been done, and it's just not. Now, for vitamin D, there is a link, but less so for C. According to Daniel, Paxlovid is in ample supply, so I don't know where you got that from. Here's a question. Some people with COVID are sitting around a campfire with people who are uninfected. Would the heat protect them from the virus? They're sitting on the other side of the fire. They're outside. And so, yes, if they're breathing, the breath has to go through the fire. Yeah, the fire would heat up the virus and inactivate it. But then, of course, they're going to go somewhere else and get into a tent or whatever, and so the fire is not going to protect them any longer. But I think the combination of being outside far away with a fire in between, not next to each other, but on opposite sides of the fire would be good, right? Now, Offit said all age groups are at risk for the theoretical problem. I don't see what the risk is if we haven't seen it pop up, as the definition that I gave is not relevant at this point because we're still using the same vaccine, right? What do you think about the Tempress inhibitor as a new COVID drug candidate? I think that's a good inhibitor. I like the idea. The problem is Omicron is less dependent on Tempress, apparently. But we'll see if there's a phase 3 trial, then we'll see if it matters or not. But I think we need more antivirals, and I think it's a good one to hit that target. Yeah, it's a cell target, right? So it's different from the viral targets. Why are so many triple and quadruple vaxxed people wearing masks? You have to ask them. I told you why I wear masks. I don't wear masks outside because I feel I'm protected. And unless I'm mandated to wear a mask, I don't. I don't think it's irrational fear. They're afraid of long COVID probably. But remember, even if you have 90% protection against severe disease and death, that means some people are going to get severe disease and die. And so they maybe want to avoid that. That's fine. I think that's the scenario. Why is it bad public health to boost yearly for COVID, but not for influenza? No snark, but just curious. Well, I don't think it's such a great idea to boost for flu every year. We have to because of antigenic drift, but this leads to low compliance, right? People don't want to get a vaccine every year. I mean, we haven't immunized enough of the world yet, and we're talking about fourth doses for certain countries. I think that's pretty obscene. But if you can avoid it, if you don't need it, then it's bad public health policy, right? If it's not necessary. For flu, it's necessary because the vaccines suck and their efficacy wanes, plus there's antigenic drift. So we have to give them. But SARS-CoV-2 vaccines don't suck. They're really good. And there's no need to get a booster every year. comment on thank you, Doreen, for your contribution to support the incubator. Comment on nasal Sputnik and others in development. So there's several nasal vectored vaccines in development. The one we did on TWIV a while ago was interesting, where they had 3 viral proteins, spike, nucleocapsid, and RNA polymerase. Adenovirus vectored intranasal. Really good broad immunity. I like that very much. But I don't know the longevity of that. There was another study recently done, which we also did on TWIV, where they used a poxvirus vector in a nasal spray, and the intramuscular was better. So I think it may in part depend on the vector that's being used. Biweekly or so snort to suppress. No, I don't think you want to snort vaccines so frequently, right? That's not necessary. The question is, does it provide a more durable mucosal immunity? Because remember, the mucosal immunity is what's going to prevent you from getting infected, or at least reduce the infection. Not going to ever prevent it, right? So that's what I think. But it's a ways off, right? It's some time before we understand their value and how they're going to be used and so forth. What is the new? All right, so you're asking that of Hazel. Well, here's the story with Camostat. So the new drug is MM3122. It's a temporase inhibitor. It's distinct from Camostat. So the problem with Camostat that I understand is that it was meant to be tried together with hydroxychloroquine, because hydroxychloroquine inhibits the endosomal protease and Camostat inhibits the plasma membrane protease temperase 2. And then after the brouhaha over hydroxychloroquine, the impetus to do the study waned, and so, I should say contracted, and so that was never done. Should we be relying on T cells? And if so, what downside does it have with multiple infections? I don't know. Should we be? We do. I think T cells are underrated. The press is just discovering them, but we've been talking about them for 2 years. I think the T cells are what save you. When you get 3 doses of a vaccine, you have good protection against severe disease and death, and that's because of T cells, because I'm sure there's some contribution of antibodies, but remember, there's always a memory response. And there was even good protection against Omicron with just those first 2 doses. Not as good as with 3, but in terms of disease. So I think the T cells are working quite well to resolve infections and prevent severe disease. So the question is whether we should be putting more T cell epitopes into the vaccines, and that can only be answered by the trials, right? Say you go on a 2-week trip to a foreign country that could lock you down if you test positive. Would it make sense to get the booster? Yeah, this is what we just talked about. So you don't get locked down. Yep. Any evidence that a booster would reduce long COVID? I don't know a study on booster, but vaccination in general, right? There is a reduction. The exact amount of reduction is not clear. I think the studies are lacking and wanting still, but it's certainly reduced. I've seen some that say it's only in half, from 20% without a vaccine to 10%. I think that doesn't make any sense to me, and something's wrong. So I don't think the answer is in yet. Thank you, Old School, for your contribution. Appreciate it. So summarizing the UK study, the finding that long COVID was 50% higher in women than men is consistent with reports from most, but not all, previous studies. Many of these studies are not in agreement with each other because they're done slightly differently. And I think it's a moving target, right? because you can't do a clinical test and say, yeah, you have long COVID. You have to ask questions, and I think that's always hard. In theory, would getting a flu shot on September 1 and another December 1 give better immunity? I realize flu isn't as bad, but from a virology perspective. Well, the flu is just a one-shot deal, right? But it wouldn't. I don't know what the effect of a booster would be. That's a good question. I don't see what harm there would be, and certainly spacing it apart would be better than putting them too close together. Campfire. Please make a video about inhaled ivermectin. I'm not sure that ivermectin warrants anything because some good trials show that it's not effective. Okay. Okay, thank you for your contribution. Any studies demonstrating asymptomatic infection exposure to virus does not evoke an adaptive immune response? No. The whether you're asymptomatic, I think the key is that the virus needs to reproduce in you, and that happens in an asymptomatic infection. Maybe that's what confuses a lot of people, is that if it's asymptomatic, it must not be replicating. But it is replicating. Many viruses do that, and they give you immunity even with an asymptomatic infection. It's very hard to study, though, right? Because if you're asymptomatic, you don't know unless you do a serological survey. I'm not aware of any studies that have been done like that. Thank you, Old School, for your contribution to the incubator. To assume that China is being truthful. I didn't say China. I said Chinese scientists. Because I know some of them, and they're mostly Western trained, and I have no reason to correct them. Now, of course, if the government is interfering and changing the data, okay, fine. I don't know anything about that. If China can get people to lock down, why can't they mandate vaccines? I don't know. Not an expert on China, obviously. That's highly recommended, I understand, but they're not mandating it, which seems crazy. Thank you, Date Bio, for your contributions. Any updates or opinion on under 5? No, I don't know what's going on with them. And I just wait for Daniel to tell. VNA, can too many subvariants change the way the vaccination works on all of them? Well, if the original Omicron evaded neutralization with antibodies from twice vaccinated people. I can't get much worse than that, right? And still, the people were protected substantially from severe disease and death, which I think is the T cell protection. So, no, I don't think that's an issue. Okay, so here's the story, folks. 2 doses of mRNA spaced 3 to 4 weeks apart is too close. This is what Amy was saying 2 years ago or a year and a half ago. And eventually I came around to get it. And I said, you were right. Okay, but she said, but apparently I did not. Give her credit when she's right. The third dose, the boost, fixed that, because now you gave the immune response a chance to mature, and you got antibodies against Omicron much better than with the first two incorrectly spaced doses. However, that's just looking at infection. The fact is that, all right, so in some studies, and it depends on the study, with 2 doses, you still had good protection against severe disease with Omicron. And with others, it went down to 85%. And the 3rd dose gives you protection against severe disease, but it depends on the study. So that's the story. I think it doesn't hurt to take a 3rd dose to fix that incorrect spacing. But I'm not entirely convinced, at least in younger, healthy people, that you need that boost. But we all have it. It's fine. Certainly in older people, in certain immunocompromised and so forth, you need that 3rd dose. The 4th, though, I see no reason for that, except to prevent infection, and it's going to decrease within 6 months anyway. And I don't think your protection against severe disease is any increased, data from Israel notwithstanding, because those are not really very good studies. I don't mind disagreeing. There's a right way and a wrong way to disagree, okay? And I can have disagreements with a lot of people. There's a one way to do it, and there's a wrong way to disagree. Have people who receive their 4th doses have their autoimmune activated? No, there's no reports of autoimmunity as a consequence of the 4th dose. Nope. Okay, so Charlie must have looked it up. Both Tamiflu and Paxlovid. Paxlovid. It's a spelling test. What could be a good policy for China's situation? Considering its huge population, new variants may appear and worsen the problem. I just think they should immunize as many people as possible. I don't know why they have to lock down. Is herd immunity possible with the virus that seems to get better at evading neutralizing antibodies? No, you can't, because herd immunity is based on the ability of antibodies to inhibit shedding and transmission, right? But if the virus is changing, then no, you can't have the typical herd immunity, but you can have herd immunity against severe disease. The more people who are vaccinated, the more people have less severe disease. And that's what we see with Omicron. Omicron in many people who are vaccinated is quite mild because they're immunized. So you do protect against severe disease, but you're still going to get transmission of the virus, and there's no way we're stopping that. You can give a booster every 6 months. You're not going to stop that transmission because you're not going to get everyone boosted. That's part of the problem. I saw an ad for an ionizing air purifier necklace that's supposed to eliminate virus in the area close to the wearer's face. Yeah, I don't think it can get everything. There's always going to be drafts of air that are going to escape it. And I don't think it's something that's going to work. Okay, you could have a high-flow positive pressure mask that doesn't touch the skin with a built-in heater or air conditioner for warm and cold days. Positive pressure. It sounds complicated. Why don't we just wear rubber suits with an oxygen supply, right? No, it's too hot. I don't know if this is feasible or not, but it sounds like it would be cumbersome and expensive. I know I'm unlikely to go to hospital or morgue, triple vax, but I'll relax when I can access Paxlovid. Yeah, it's fine. That's what people should be able to do, is have access to an antiviral. But remember, you can't wait until you feel really bad, because then it's too late. So you have to decide when to take your Paxlovid. I know a very healthy young lady in her 20s who was triple vaxxed and got In fact, if she had moderate symptoms, she went to her doctor. The doctor gave her Paxlovid. She said overnight she felt no symptoms. So maybe that's the thing. You can't wait. If you're symptomatic, just get Paxlovid. Because there's nothing I can tell you that would, I mean, if you wait, let me see if it gets serious. Oh, I'll wait until I can't breathe. No, then an antiviral is not going to work, right? So Mexico will vaccinate younger children sometime after April. Excellent. I'm glad to hear that. Why are we seeing more recombinants? I don't know. I think we've always been doing genome sequencing, right? So we're not doing more sequencing. It may be that there are more multiple infections going on now than there were before. I don't know the answer. It's a good question. I'm not sure we actually are, but it would be an interesting question to ask someone who knows the genomics better than I do. Chocolate croissants, huh? There's a place across the street from the incubator. It's Le Pain Quotidien. They have really good chocolate croissants. Yep. Now we're going through some bagel talk. That's why I'm trying to find a question. While I'm looking, folks, we have 500 of you here. Could you give it a thumbs up? We're below 300. Thank you very much. I really appreciate it. So anyway, I'll be in D.C. in June. So remember, I'm going to Nebraska, Omaha in May. I'm going to Zurich in May, but I don't think there's anyone from Zurich here. Many of us with long COVID have had it for 2+ years. Long haul COVID groups are still going strong. I still have symptoms, not just every day. I understand, but I think there's still a lot of clarification that has to be done with respect to vaccinated people getting long COVID and the mechanism so that we can develop treatments. Now look at that. It went right up. It went right up to 342. Thank you so much. Is it possible to create a new virus from extracting fragments of genes from every existing virus to artificially create a supervirus? I don't know how you would do that. What would you add? Right? Mix and match is not going to work because a herpes virus gene is not going to work with a influenza virus. They're incompatible. So no, you can't do that. I don't think we can make super viruses. We just don't have the understanding of what all the genes do to be able to do that. Oh, this is a tough one, Jessica. The most outstanding discovery in immunology in the past 2 years. No, I got to go further back than 2 years. So you want to know fundamental immunology, because mRNA vaccines are pretty cool immunology, and so is CAR T cells, right? The idea that you can program T cells to hit a tumor, and also checkpoint therapy to wake up exhausted T cells. I think those are all very cool. But if you go back even further into the 80s, I think the discovery of how antibody genes come together to make antibodies, and then subsequently somatic hypermutation is so cool. But that's old. I know it's not in the last 2 years. And neither is CAR T cell or checkpoint therapy. But that's the best I can do. I did answer the campfire question, Caroline, so I don't know what you're referring to. I'm worried about getting a booster because of the information in the Pfizer papers. You had 2 vaccines a little less than 3 weeks apart. All right, what are you worried about? What's in the papers that worries you? Many people have got boosters and they're fine, so I don't know what you're worried about. I don't think you should be worried. That first variant was bad. My husband got it, hospital twice, had to isolate, think lots of long-lasting symptoms. Well, anyone's individual experience, it's not necessarily indicative of the overall effect of a variant, right? So that's very difficult to do. Once you get COVID, how long are you protected before you can get it again? Again, what do you mean by get it? Just get PCR positive or actually get symptomatic disease? So if you're fully vaccinated, then you got COVID, within 6 months, you're going to be infected, but you're going to get mild disease. You're not going to end up in the hospital. But within 6 months after infection or vaccine, you're going to be the most protected against infection. Are COVID counts, deaths undercounted? Excess deaths show a gap. Yes, we did a paper last year on TWIV about calculating excess mortality, and yes, they're undercounted. In some countries they're overcounted, but in some they are undercounted. Since inflammation happens after most viable virus is cleared, are there any studies investigating which protein might be responsible for the immune response? Well, it's probably something triggering innate immunity, right, which involves sensing either a protein or an RNA and then leading to the synthesis of cytokines. And I don't know that people have looked at that. Not at all, but it's obviously an interesting problem. All right. We are getting near the end. Let me just see if there are any more pressing questions. What might be a mechanism for COVID vaccination and cardiac problems? I don't know. So some people suggest that a little bit of the vaccine is getting intravenous, and that gets to the heart and causes damage. And there was a paper published last year which didn't get much attention. I don't know how good it is, frankly, but they put mRNA vaccine intravenously into mice, and they developed heart problems. And if they put it intramuscular, they did not. So that may be part of it, that the stray nanoparticles are somehow getting to the heart. But it could also be related to inflammation. Yes, for sure. Let's see here. Okay, time to wrap this up, folks. Thank you, Michael, for your contribution. With respect to viral shedding following a resolution of symptoms, am I correct in assuming some viral remnants? Is there such a thing as a non-infectious viral fragment? Yes. Well, you have to have an intact virus to get infectivity. And as you progress if you go past the symptoms, you're making less virus, and virus that's been around is breaking up. There's immune responses responsible for that as well. So that's why positivity is not always infectivity. Okay, thank you, Morris, for your contribution to science education at the incubator. Zipping through your comments and questions here because it's time to wrap up. And that'll do it. Thanks, everybody, for coming tonight. If you didn't get your question answered, come again next week. We're here. Am I here next week? Yes, I'm here next week. I want to thank the moderators, Steph, Les, Frank, Vanity Nutrition, and Tom. Kind of thankless work. Thanks, everybody, for coming. Thank you, Mystery Find, for your contribution. And don't forget that there's a TWIV dropping at midnight. It's called Molnupiravir with Richard Plemper, and pretty interesting, all about antiviral drugs. So until next time, folks, take care of yourselves, be safe, and see you next week. Good night.